Okay, this is Dr. Esterline again in the chemistry lab. We are going to be doing an experiment calculating R in the equation PV equals nRT. This is experiment number 8, evaluating the gas law constant. So let me turn around the camera here. It's going to be a bit challenging because sometimes I need two hands and I've got to hold this phone. So experiment 8, evaluating the gas laws. You can see right here we're going to use PV equals nRT. And we're going to calculate R. So we need pressure, volume, moles, and temperature. And what I shared with everyone else in class is that for P, you needed an atmosphere, so you're going to have to use this conversion factor. 1 atmosphere equals 760 millimeters of mercury, because we have a barometer in the other lab, and I just read the barometer, and it shows a pressure of 74.42 centimeters of mercury, which if you multiply that by 10, you get millimeters. Centimeters to millimeters, the difference is 10. So it's 744.2 millimeters of mercury. You're going to need that pressure, and it goes on your data sheet. So this is page 1. The back is page 2. The next page is your data sheet. So on your data sheet, atmospheric pressure is millimeters of mercury right here. Vapor pressure of water, we get that from the temperature in the room. And the temperature in the room is 18 degrees Celsius, which we would normally pull out vapor pressure from this table. So at 20 degrees, vapor pressure is 17.5 millimeters of mercury. 21, 22, so it only goes up from 20. So we had to kind of estimate, what is it at 18? It's cold in the lab today. So here we have the number at 20 degrees Celsius at 17.5, and 21, 18.6. Well, the difference is 1.1, so we just use that to go from 20 to 19, subtract off 1.1, 17.5 becomes 16.4. To go from 19 to 18, subtract off 1.1, so 16.4 becomes 15.3. So we're going to use 15.3 millimeters of mercury for our vapor pressure of water, 15.3. You're going to use that in the calculator. So far we've got 744.2 millimeters of mercury for atmospheric pressure, and vapor pressure is 15.3. We also need the temperature, volume, and gas. So to get the temperature, just want to finish here. Pressure has to be in atmospheres, right? So use this conversion. You're going to have to change your millimeters of mercury to atmosphere. Volume has to be in liters, so you got to use this conversion. 1 liter is 1,000 milliliters. N is moles. We're going to weigh in grams of magnesium. So for grams of magnesium, you change that to moles by using the periodic table. You can see that 1 mole of magnesium equals 24.305, right there, 24.305 grams of magnesium. 1 mole of magnesium equals 24.305 grams. So you're going to convert grams to moles. In fact, let's get that number right now. We need to have the mass of magnesium. So let's go get that mass of magnesium. We have a big roll. Sorry. Cover your eyes if this is making you dizzy. I'm going to be all over the lab. This is our magnesium strip, magnesium metal. I cut off pieces that were the proper amount. The procedure says to weigh out somewhere near 0.04 grams. So I have these pieces that I cut for each student. And then I took one and I folded it because it has to fit down into our gas tube. So now let's weigh this. Put it on the balance, close the door. You're going to record as your mass of magnesium 0.0433 grams. 0.0433 grams. So you're going to change from grams of magnesium to moles of magnesium, and then from moles of magnesium to moles of hydrogen gas. And you get that from this balanced equation. 1 mole of magnesium is reacting with 2 moles of HCl to make 1 mole of hydrogen gas and magnesium chloride. So it's this 1 mole to 1 mole relationship in, right, it's on the first page. This is the reaction that we're doing. It's 1 mole to 1 mole. Sorry, the hydrogen. Magnesium to hydrogen. We weighed the magnesium. You're going to change it to moles, right? Using 1 mole equals 24.305 grams. I took that from the periodic table, 24.305 grams. And then once you have it in moles, you're going to use 1 mole of magnesium to 1 mole of hydrogen gas to get moles of hydrogen gas. All right, so that's going to give us N moles of hydrogen gas. R is a constant. They tell you in the book it's 0.0821. You are going to calculate this number and compare it to this known value. Right, so you're going to compare accuracy. You're going to see if you get the same answer. And then T is temperature. Temperature has to be in Kelvin, but we use in the lab degrees Celsius. So to change degrees Celsius to Kelvin, you have to add 273, or you can use the number 273.15. Add those numbers and you get Kelvin. Okay, so that's the other thing we need. We have mass of magnesium now. We've got atmospheric pressure and vapor pressure. We just need volume of gas and temperature. Let's get the temperature and then we'll get the volume of the gas. We're running this reaction in this tank. And the temperature in this room right now should be the same as this tank. It is, I'll let you read that yourself. Hopefully, I think that's clear. You want to record it to the tenths. All right. So I'm not going to tell you that number. I want you to determine that number. You're between 10 and 20. And if you have trouble with that, let me know. And I will help you, but hopefully you can read that number, right? I'm trying to get it to focus on this better. There we go. You have to read that number. All right. Looks like it's pretty close to 16, but it's just a hair, I'll say below. So I'm going to say 15.9. Dang it, I read it for you. Okay, we're going to run the reaction in this tank using this tube. So this long tube is closed on one end and open on the other. And I have to put, I'm reacting 2 ingredients, magnesium and HCl. So I have to get those 2 things in here and then we're ready to go. First, let's go get the HCl. It's all the way over in the hood here. I pre-measured, the procedure says 5 milliliters. So we got 5 milliliters. See if I can do this. I'm gonna pour it into this tube from here, 5 milliliters. And this is not something that you have to measure. I've already pre-measured it. So this is concentrated hydrochloric acid. And I just added 5 milliliters. Okay, so we got one active ingredient. The other one is the magnesium that we weighed. That little strip of magnesium that we weighed over here. And I folded, it's sitting right here. So I need one more thing before I can throw in the magnesium. I need to fill this tube all the way up with water. So let's see if I can show you this as I do it. This is tricky. With one hand holding the camera. So you see that gas coming off? That's hydrochloric acid. It's a gas, but we purchase it dissolved in water. So I need enough in here to make this just bubble up so it's absolutely full. So completely full of water. Okay, so now I'm gonna have to set this down a second because I gotta pick up the strip of magnesium, set it on top. So you can see the magnesium, it's setting right there. Sorry, this will not focus, but the magnesium's sitting right on top. So I hit it, the magnesium starts sinking. It's sinking into this tube. It's going to go down. So now it's rising because it's reacting with the hydrochloric acid and it's bubbling. I turn it upside down in this tank, take my finger off. Okay, sorry, I had to use my other hand. So now I have it in the tank. And the magnesium, I'll bring it over to the side, see if you can see the magnesium. Magnesium's in there. It's reacting with the hydrochloric acid, and it's producing hydrogen gas. Right, so remember, Mg plus HCl, so it's magnesium plus hydrochloric acid, reacting, producing hydrogen gas. We're trapping the hydrogen gas in the closed end of this tube, and it filled up all the way down to here. It's still reacting and bubbling, right? Making hydrogen gas plus magnesium chloride. Magnesium chloride is a salt that stays dissolved in the solution. Okay, so it's almost completely done. So now that it's done, I have to bring the level of the liquid inside of the tube up even with the level of the liquid in the tank, which is like right there. And then I have to read this. Okay. So you try to read it first. It's between 46 and 45. I don't have an extra hand, but right here where my pinky is, that's 45. Down there is 46, down in the water. So we are, apologize, this is going to be hard for you to read. Maybe that's better. Yeah, with my hand behind it. You can see the lines a little bit better. So you see the bubble of water inside of that tube. Looks like it's below 45.5. Do you see the 45? The line above the 4 of the 45, the longer line is that 45.0. The line below the 45, right below the 4, that is out of focus, dang you. That is 45.5, and we're below that. Shoot. I'm going to say 45 points. I got to get this out of the way so I can read it. It's almost right on 45.5. It's just a hair below that. So I'm going to say 45 point. Looks different in the camera. 45.40. I'm just going to say 45.40. Yes, that's pretty close. 45.40. So I can let this out. 45.40 milliliters for the amount of gas that we collected. Right, we just ran this reaction. Magnesium and HCl became hydrogen gas and magnesium chloride. And we determined that the volume of this gas, 45.40 milliliters. Okay, so now you have everything you need. You're going to do the calculations, converting mass to moles of magnesium, and then moles of magnesium to moles of hydrogen gas. And then the milliliters, the 45.40 milliliters to liters, right? Using the 1 liter equals 1,000 milliliters. You're going to convert temperature to Kelvin, right? The temperature of the water tank. Remember, you just add 273.15. Then you're going to calculate the pressure of the hydrogen gas by taking the atmospheric pressure minus the water pressure. So that's as simple as just subtracting these two bottom numbers, right? Atmospheric pressure minus vapor pressure. And then you're going to convert from millimeters of mercury to atmospheres, right? Millimeters of mercury to atmospheres using that 1 atmosphere equals 760 millimeters of mercury. Finally, you're going to take all those answers, you're going to plug them in to PV equals nRT. We've got the pressure, the volume, the moles, and the temperature. You're going to solve for R. And you got to do that for 3 trials. I'll upload this with a picture of someone's data so that you can fill out the table, which has a trial 2 and trial 3. Right? We just did trial 1. So you average those. I think I told everyone in my class to, when you calculate R, you got to do 3 calculations for R, trial 1, trial 2, trial 3. Take the 2 that are the closest and average them. So for calculation 8, average the 2 closest R values, and then you're going to calculate percent error, which is your experimental average that you got for R, minus the true value, which they tell you on the very first page. The true value is right here, 0.0821. So your value from calculation number 8 minus 0.0821 divided by, that answer divided by 0.0821 times 100. So the one thing that's missing in this calculation is you make that positive, right? So it's absolute value. It's the difference. It's not a negative value. Okay, so if you have any questions, ask your professor. Kind of a fun experiment that you missed, evaluating the gas law constant. When you're done with those calculations, there's just one more page. These post-lab questions, right? So you get to do those as well. There's 3 parts to one, and then question number 2. Okay, I'm out.